You were starting, Isabel, or somebody was starting on something?
Yeah, I was just looking through my notes, seeing like what I had some questions on. Sorry.
No, that's fine.
Can we go over the reaction where it was like hemiacetal and then sorry, my printer is like going crazy. Where it's like hemiacetal and hemiketal, or it was like the last reaction we did. I was kind of confused on that.
Okay, so if we start with an aldehyde, and we'll make it specific. We'll use like specific group. So what I can do is I can add one or two equivalents of an alcohol. So let's make that like methanol. So depending on whether you have one or two equivalents of this, it's going to be an equilibrium reaction, and we need acid as the catalyst. So overall, what's going to happen is that we're first going to form we're going to have an OH and we're going to have the OCH3. So we're going to add one equivalent of methanol to the carbonyl. So this is a hemi. And in this case, because it came from an aldehyde, meaning that there's an OH, an OR, one alkyl group, and one hydrogen. That hydrogen means that it came from an aldehyde, so this is then called the hemiacetal. If I changed this and had another alkyl group on the other side and it was a ketone, it would be technically a hemiketal. And then when I do the second equivalent of methanol, I'm going to replace the OH with that OCH3 group. So this would be, in this case, a full-blown acetal. So there's two different species you can get depending on whether you use one or two equivalents of the alcohol to begin with. So in terms of writing the mechanism of that, the first step is always to add the acid to the carbonyl group. And so when I protonate the carbonyl group, I'm just going to have one pair of electrons, and I'm going to have the positive charge. So I'm protonating the carbonyl like I would protonate any other oxygen.
Okay.
Then the next step is, and the reason I do that is because that's going to put more plus charge on the carbon, because you could write a resonance structure by taking this pair of electrons on the double bond and giving it to that oxygen. Which would then put a positive charge on the carbon. So when we protonate the oxygen, we're actually making the carbon more delta positive, and the fact that it's more delta positive would then mean that a weak nucleophile like methanol could come in and add. So the methanol would come in and add either to the carbocation if you want to write that resonance structure, or if you write the resonance structure over here, when the O comes in and attacks the carbon, then the pair of electrons goes up to the oxygen. And you can write either one of those, it doesn't matter, because they're all going to give the same product, which is to have the OH up here and have the entire CH3OH group add to that carbon.
Okay.
So then next step, lose the H plus. And so then we'll form the hemi, in this case, the hemiacetal. Is everybody okay with that?
Yes.
Katie?
Yeah.
Okay. So then the question is, where do we go from here? And we need, so we lost this H plus. The H plus is always going to be there. We lost the H plus. Now we're going to react either the OH or the OCH3 with the H plus. If we reacted the OCH3, if we react the OCH3 with the H plus, I'm going backwards, which is why there's equilibrium arrows, why there should be equilibrium arrows in each one of these steps, except these two because those two are the resonance, those are resonance structures. But if I took my proton and I protonated the OCH3, it'll go backwards to form this, which then this would leave. So the reason equilibrium arrows are because every one of these steps can go forwards or they can go backwards. So in order to move the reaction forward, what I need to do is I need to protonate the OH. And so if I protonate the OH, I'm going to end up with an equilibrium step to now form that oxonium ion. Right. And then the next step is to go ahead and lose water. So I formed that carbocation. And of course, if the water comes in, if the water would come in and attack the carbocation, I would go back through the reverse steps. But now what I want to do is take my second equivalent of the methanol and have it add to the carbocation to keep moving forward here. And again, I have to add the whole alcohol molecule. So I form the oxonium ion. And then just like whenever you add a neutral nucleophile to a carbocation, the next step is always to lose the H+. And then I form my final product.
Okay. That makes more sense. Thank you.
You just have to break it down step by step, and this is a mechanism that I could ask you to do on the exam.
Okay. I don't really have any more questions from that video, but would we be able to do an example of like a heck coupling?
Yeah. Let me get a new screen. Okay, so we have to remember what's heck. I guess I have to remember what heck is.
Oh, sorry.
No, well, see, the thing is, when for this exam, it's essentially open notes, open book.
Mm-hmm.
So depending on how much time you have and how organized you are, you're going to be able to, consult with the different with your notes. So I don't have my notes in front of me, so I guess I have to remember it from scratch, but that's okay. The way I remember heck is that there's two types of couplings. There's one with the boron. There's one where you're going to couple the alkyl halide with the boron, and that's Suzuki. And that's much more versatile because I can put any group pretty much I want on the boron. But over here, the problem is that that's pretty much the only molecule that I gave you for doing heck. So you're going to react the bromobenzene with the alkene, and that's really all you can react it with. And then the palladium is like palladium acetate, and then there's the triphenyl. I just remember the triphenyl phosphine. And so the heck coupling is really only good if you want to couple, if you want to take that double bond and then couple it to the benzene ring. And the thing, Suzuki is much more powerful because depending on what R group I put on the ring, or what R group I put on the boron, I can pretty much add anything here. The problem is with the heck coupling, it's only this kind of molecule that I'm adding.
Okay. So then when you take away the bromine, you just keep that bond and you just like,
Yeah, that's where people are most likely to make a mistake, is that they'll do something like this. And that's going to be wrong because the carbon has 5 bonds. So whenever you're doing one of these coupling reactions, Heck or Suzuki, the best thing to do is just say, okay, there's my bromine. Let me erase my bromine. And now let me add on the group that I need to add on. So this bond right here is, you want to make sure that you don't forget to keep that bond.
okay. Okay, that makes sense. Thanks. If there's no more questions, can we just do some like example problems with the reagents we used last time? Sometimes like I have trouble like getting to the final product, like using the reagents.
Sure, we could do that. Everybody okay with that?
Mm-hmm.
Let's see, I'll have to think. Let's see, let me save that. Let's see, I don't want to give all the good problems away because I want to save those for the exam. Let's see. I'm going to violate my rules here, and I'm going to violate my rules and add something that I haven't talked about in this optional session.
Okay.
So let's say I gave you this one. So we have to think about how we're going to add this OR group. So just thinking it through, what are we going to have to do? We're going to have to add a nitro group, convert it to an NH2 group, convert it to an N triple bond N plus group, and then finally add the OH group. Okay, and so we can do that. And then down here, we could add the carbonyl group by simply adding the acid chloride and aluminum trichloride. So one reagent there will work, but we need multiple steps to do the nitro group. So the thing to think about here would be, okay, which group do I want to add first? It actually wouldn't matter. I could add the nitro group first and then add the carbonyl because the nitro is going to direct meta. can't add the nitro and then convert it to NH2 and then add this group. I could make the diazonium and then add this group. So the sequencing of the reagents is, there's more than one way to do this. But probably, I guess, the most direct way would be to say, okay, let's just go ahead and put on the carbonyl group. And then after I put the carbonyl group on, let's put the nitro group on. Then let's convert the nitro group to the amine. And then let's convert it to the diazonium. And then let's put the OH group on. So we're just one reaction away from what we need. But so when we've done this reaction before, this group, this alkyl group, has been primary or secondary. And so you might say, well, it's tertiary in this case. So what I can't do, if it's tertiary, I cannot do the following. I can't take the alkoxide and add it to the tertiary halide. Okay. I can't do that reaction because the tertiary halide won't undergo SN2. So if I want this to be an SN2 reaction, it won't be. It'll be E2. So if you want to put a tertiary, so if you need to put a tertiary alkyl group on the oxygen to make the ether, you need to just use two alcohols, put two alcohols together. And what do I mean by that? I mean, we would just keep the phenol, and now react it with tertiary butyl alcohol with acid as the catalyst. So that what would happen is, so this is the way to add tertiary alkyl groups to form an ether. So what would happen here is, you could say, how about protonating the OH attached to the benzene ring? You could do that, but you can't form a carbocation on it. So what we would do is we'd just simply protonate the tertiary-butyl group, the tertiary-butyl alcohol. It would form it's going to form an oxonium ion. I'm then going to lose my water to form the carbocation. And then the phenol would come in, add to the carbocation. To form the protonated ether, and then I should erase that H and write it a little bit better. So let me put in the O and the H up here. So then I would go ahead and lose the H plus to form the product. So we didn't really talk about, although there's some in the practice problems and the, tons of practice problems there are, we didn't talk about how to add a tertiary group to make an ether. So this sequence right here, that sequence would be the way to add a tertiary group. You have to do that by using basically, I guess, an SN1 mechanism instead of SN2.
So would we actually, like, if we were given a problem like that, like write that side reaction out underneath the problem to like show how we got to?
I'm showing you this mechanism here just to show you how it works, and
Okay.
mostly to show other people, if they watch this video, because if you, as I've suggested with me recording this, I'm not recording it so there's another hour of video to watch, but I'm just recording it so if people take a look at the notes and they're like, wait, what's that? They can immediately fast forward to that point and say, oh, okay. And here what I'm doing is showing you how you would add a tertiary group. And I'm showing you what the mechanism would be because it's not something brand new. It's something we've done in the past.
Mm-hmm.
What I would ask you to do, for instance, what you would do here is down here, you would say in the final step, let's add tertiary butyl alcohol and H plus, and then that would get you the final product.
Okay.
And then after you've designed how you're going to make the molecule, you would go back and put in your reagents. So this is where we would put in each one of the reagents into this, into the scheme.
Okay.
But I'm going to ask you to write the scheme out and include the reagents. And it can be as many steps as you need to get there, or in as few or as many. But the problem here is to add the OH group, it takes 1, 2, 3, 4 steps automatically to get the OH group on there.
Okay.
So you can't do that in less steps. You've got to do it in those 4 steps.
Okay. Thank you. That makes sense.
And and the sequencing makes a difference. Let me just add on. The reactions that people used that were the most common mistakes on the quiz questions that people turned in were, they tried to do this. They tried to add the straight chained alkyl group in one step. Sometimes they had a nitro group on the ring. And when they went to add their alkyl group, their generic alkyl group, somehow that group got para instead of meta. So you could add this straight chained alkyl group if you use something like a Gilman or even a Suzuki coupling. You could do this, but what they tried to do was they tried to add the straight chained alkyl group with aluminum trichloride, and you don't get that product. You get the isopropyl group. And the same thing down here, nitro is a meta director, and so it directs the alkyl group, not here, but it directs it there. So, and I think part of the confusion was that when you're adding when the group that you're adding is not directing itself, it's being told where to go from the group that's already on the ring. And this is always, and you always have to watch out for straight chained, because you can't add a straight chained alkyl group with Friedel-Crafts. Because what will happen is the aluminum will pull the chloride off, but then the hydrogen will shift over. So you'll end up with a hydrogen shift. And you'll always end up with the plus charge on the second carbon. And I show where that hydrogen went. So you'll always end up with the secondary carbocation, not the primary one, or not adding the primary group.
Okay.
So when you're going through your synthesis, you just want to make sure that all your steps are legal, that you've got the groups going in the right positions, and that you're not using a reagent and not getting the proper product. And that's also for anybody who's looking at this, after this, and made those mistakes. You want to make sure that you don't do either one of those.
So what does the test completely cover? Is it what we started? I don't know where we started.
Well, that's a good question. So let's think that through. So we stopped on the last test at aromaticity, right? Whether it was aromatic, not aromatic, or anti-aromatic. So so the exam material is going to start with so the reactions that we started to do with benzene. Now, before we started adding electrophiles, we had that if you had an alkyl benzene, you could convert it to a carboxylic acid with KMNO4. We had that if you took the benzene ring and you reacted it with sodium in liquid ammonia, that you, let me add an R group here, so you ended up removing the aromaticity, and you ended up forming a non-conjugated diene. That was Birch reduction. And we also talked about if you had an alkyl group and you treated it with something like NBS, that you always brominate in the benzylic position. The benzylic position is the most selective position. So I'll go back and see in the book where which topics those are.
Okay.
But those were the reactions that those were the reactions that we had before. So all three of these reactions came before we started to add things to the benzene ring, before we started to do electrophilic aromatic substitution. And then it'll cover through the acetals and ketals, hemiacetals, hemiketals, that was on Monday's video, the video for Monday. And the quiz for Monday.
Okay.
And then the video I put up yesterday, Monday's going to be an awkward day. In the scheme of things, Monday's going to be awkward simply because the exam's not due until midnight. I'm not sure that people are going to be all that excited about going over Wednesday's video, the video that I put up for today, on Monday, because they're trying to finish the exam or they're still working on the exam. So I'm kind of making the video today, Wednesday, is probably going to be for, it'll be for sort of next Wednesday, but I can still answer questions about it on Monday.
Okay.
I'll probably post another video for Monday, just simply because that way I've got something in there for class time.
Okay.
But I'll try, I just need to finish up chapter 22, 23. No, chapter 22. So hopefully it'll be less than 50 minutes. Wherever I end in chapter 22, I will stop. I'm not going to just use the 50 minutes to use the 50 minutes. But yeah, then we won't have, on Friday, I'll have the exam up and released at 8 o'clock so that you can go in and get it, and then it'll be due by midnight on Monday. And I'll probably, when I post that exam, I think I'm going to do a quick video, because in Canvas I can attach a video to the link. So I'll probably just outline the rules for this, because I'm going to have some sort of line that says that you have to sign that says I did this myself.
Okay.
Of course, if you're, You can always sign that. I mean, I'm not going to ask you to sign it in blood. That's between you. That's between you and your conscience as to whether or not you sign that and it's true or not. But hopefully hopefully this hasn't, taken the ethical nature of everybody away yet. Maybe by the 4th exam. But it essentially will be open. It'll essentially be open notes. So that's where organization is going to be helpful. And I came up with those rules before I realized that everybody can Zoom each other. I didn't realize they were going to give students the ability to Zoom to each other. Because now I'm finding people are just Zooming for like hours a day talking to each other. Which is fine. I mean, we need some sort of human contact, even if it's through a video screen.
I had like one other question, but it's about the quiz. I already took it, but I just had, can I still ask it or?
Yeah, I don't. Let me let me let me pull it up and I'll share the screen.
Okay.
Okay. Wait, I already loaded up Canvas. The quiz for today.
Yes.
Yeah. The quiz that goes with today's material is just how's it going? Because they suggested that would be a good thing to ask at this point formally. So it's a random quiz. So let me go back to March 23rd, online quiz. Let me go back. I know because you can't see anything because let me make sure I save. And I'm going to do a new share. Okay, so let's do the preview. And let me get. Oh, okay.
Okay, so for like number 5 and 6, those are just oxidations, right? So that would just be like the strong or mild oxidation.
Let's see. I am going to need to pull up the lecture. I'm going to need to pull up the lecture notes for that. So let me pull them up. Okay, so reactions 5 and 6.
Yeah.
Okay. So mild and strong. Yes.
Okay. I just wanted to make sure that I did that.
Yes. You want the reagents that take the primary alcohol and make the aldehyde out of it, because remember, a primary alcohol with a strong oxidizer will go to a carboxylic acid.
Okay.
But it is possible to have the reagent that you use in question 6 also be valid for question 5.
Okay. And then you can use like any of the strong or mild, right?
Yeah, when I put the key in for the quiz, number 1, I have to go through and grade those. So I'll start grading them today, and then I'll finish them up tomorrow morning. But there's no artificial intelligence with Canvas, meaning that I can't say, oh, KMNO4, if you have KMNO4 with a big M or a small m, it's different. So I tried to type in all the different combinations so it would mark as many correct as possible. But there's all these different combinations of things, so I have to go through and quickly grade them by hand to see if it makes sense.
Okay.
So people are going to get freaked out when they get like one correct, because your answer didn't exactly match my answer.
Okay.
It's exactly what happened in lab last semester with those online quizzes. They all had to be graded by hand because they just don't have the ability to, it doesn't have the ability to say, oh, that's close enough.
Okay. Yeah, that was the only one that I had a question on. Thank you.
And the hint there is that I think when I wrote these, I kind of had the same order as they are in Top Hat. So if you didn't go back through your notes and look at them, I think most of them are actually in Top Hat in order.
I think that was all the questions I had. Thank you.
Any others? Questions about anything? How are your other classes going?
They're going okay. I have my first like lockdown browser exam tonight, so that should be interesting, but
Do you have to take a picture or a video of your surroundings to make sure there's nothing there?
yeah, and then you have to like count to 10 and then like you have to like move around to like make sure that it's you. It's like weird. I don't know.
Yeah, I think we'll wait until the final exam to do that.
Yeah. I'll let you know how it goes.
Oh, I've been hearing how things are going. That I've been hearing. I mean, we're still only in, what day is this? This is day 8. Day 2 of being locked down in Ohio. Although now everybody's locked down.
Yeah.
In Pennsylvania and Michigan, everybody's working from home. Unless you have your paper that lets you drive into work.
Mm-hmm. It's crazy.
Which the police said they're not going to pull anybody over to make sure, but
Just to be safe.
I don't know. I got mine. I need to go into the building, which I don't have to right at the moment.
Are the buildings at John Carroll like closed down, like you can't even get in, or can you still get in?
As of Monday, if you had, students could get in with their ID to Dolan between like 8 and 5, and faculty could get in 24/7. But then they asked us to fill out all this paperwork on Sunday night in a mad rush to see who was essential and who was not essential. And so then I had to ask people, can they do this stuff from home? Because I know at least one chemistry person who doesn't have internet at home. So that's going to be kind of a limitation there. And some faculty are just putting up notes, and that's the best they can do. I mean, even my internet here is flaky because of, I mean, I've got it working like 2 minutes before I logged on, but it's, I don't know, maybe I have too many devices attached to it, and they're telling me you can only have so many. My Google's like, I can't, your internet isn't working. Well, of course it's working. But as long as I can do this, I mean, but some people, it's the best you can do. And if I don't have access to this, then I have to write everything out on my iPad and upload it. So we're just beginning this, unfortunately. So it's a long haul. We're not even to Easter yet.
Yeah.
And then once Easter's over, then we'll get to the finals, and then who knows what the summer is going to bring. I don't know. Too much uncertainty.
Yeah. Is John Carroll still doing like summer classes, or is that just completely
I
canceled?
have no idea. I will be more than willing to teach online organic. But then the problem is most of the students, when I teach online organic, when I taught organic last summer, most of the students were from not John Carroll. They were taking it because they were home in Cleveland. So all these other universities now have online versions of their classes. So why would they come here? I mean, the answer is obvious why they would take my class versus somebody else's, but but how do I market that? So I'm more than willing to do it. Lab, I have no idea what happens with lab. I have no idea how you do organic one lab online.
Yeah.
And if I could, it would take me a tremendous amount of time and a lot of videos, but then I have to get into the building to be able to do it. So right now they're discouraging people from being on campus unless you absolutely positively need to be there. And I guess that's in line with all of the other suggestions.
Mm-hmm.
I haven't been to the grocery store since Saturday to see what exactly is out there. There were no eggs on Saturday night.
Oh no.
There were egg beaters. I almost bought a couple cartons of egg beaters just in case, but I still have some eggs. This is insane.
I know.
I never thought I'd see this.
Me neither.
But all we can do is just keep moving forward. So, all right, anything else?
Nope. Thank you.
Okay. Then I guess I'll entertain clarifying questions for when I put the exam up, but otherwise, other than that, then I'm not going to have one of these on Friday, so that way everybody can work on the exam, but I will be here on Monday.
Okay. Thank you.
Okay. Take care.
Thank you.